Welcome back to Labs in the Time of Coronavirus. This is a video that I'm putting together with um, our lab setup gal, Natalie Larimore. She's over there. Okay, it doesn't show her because of the virtual background.
I'm here.
She's here. She's a real person, I swear. I'm not throwing my voice through this mask. So what we're doing here is basically showing how to use Teams to work together virtually in the labs. What I'm going to do in this video is basically screen share with her so that you can see how screen sharing works. I'm going to try to give her control of the computer. I'll at least show you how it's done. I won't guarantee results here because the laptop she's using is kind of misbehaving today. Hopefully it will give her control, and then we're going to reverse, sort of switch positions so that she can show me her background so that you can see what that looks like, and she'll give me control, which has also been a little funky. And then we'll walk through basic Pasco setup. Okay, so first of all, if I want to share whatever's on my screen, I just push this open share tray button. It gives a whole bunch of options. I prefer to share my entire screen, so everything that is on my screen, if I switch programs, it continues to share it without having to click any new buttons. That is screen number 2 for me. For you, it may not have that option because you don't have multiple monitors. Okay, and so that pulls up whatever I have. So you can, here's the faculty protocols for Troy Strong. So Natalie should be requesting control. Here it is. It's popped up here at the top. I click allow. Yay, it worked. Okay, so now you can see her mouse. And by the way, I still have some control of this. I'm scrolling right now. Now she's scrolling. She's going to click on an FAQ. How will faculty be notified if a student in their class is positive for, it tells you. This is true, by the way, only if the student notifies the dean or if their testing center notifies the dean, for what it's worth. And now, I can still scroll up and down on this. I can go down and look up what the university's metrics are to guide its decision before closing campus. And why we're meeting this way instead of online. In any case, and we can open up other stuff. Now, what I actually want to do with this a little bit is I want to walk through some basic Pasco setup using, we can do it for either one of these 2 labs. It's actually set up at the moment for the Freefall Kinematics with PhotoGate and Picket Fence lab. Okay, so what I'm going to do here is, let's see, Natalie is not controlling it anymore. What we're going to do is I'm going to stop my screen share. She's going to start sharing her screen with me. Okay, so this should let me see whatever she's got open on the desktop. There it is. Okay, and I'm going to request control. So there's a little button here that says request control, and she's allowing it, and hooray, we don't have the stupid problem that we were having earlier. Okay, so let's set this up for that lab. The first thing we do, first of all, we've opened up Pasco Capstone. We go to hardware setup, we click on that, we click on the port where the PhotoGate has been set up, and this one actually only gives you the PhotoGate option. Some of them are set up so that you can click directly on PhotoGate with Picket or with Picket Fence. If they do, then you just click that and you're done. If they don't, you click PhotoGate, and then you have to go to timer setup. It's a pre-configured timer. Next, it's PhotoGate channel 1, correct. Next, set up the timer, and we are using a Picket Fence. And then the rest of this should be fine. Flag spacing, you actually will want to measure that. I'm going to leave it alone, but you could measure it and check and make sure that it is actually 0.05 meters. Next, finish, and we're done. We've done it. So now we can click on this to get it out of the way. And then what you'll need is 4 displays. So you need, you need a, that's not what I wanted at all. You wanted a graph here. You want probably a graph here. You want a graph here. And you want a data table here. So, table. This graph right here, we click on, we select position, and it will automatically say position and time. This one I'll go ahead and turn into acceleration. This one right here will be speed. This right here will be the time, and this can be the position. Okay. So now that we've got all that, we're basically ready to run the experiment. So I click record, and then Natalie will drop the picket fence through. So ready, record, drop, and it now has a bunch of dots and a bunch of positions and so on. 1, 2, 3, 4, 5. Looks like it didn't. No, it did. 6, 7. 7 positions. That's correct. Okay, so first of all, we're going to want to configure all the graphs so that we can actually see what's going on here. So I'm basically clicking on the axis when I get the little double arrow like this and stretching the time axis out so that I can see. And now I'm stretching the position axis out so I can see. And looking at this graph, it should be clear that this is not a line. Okay, now let's do the same thing for speed and time. I actually want to have about the same axis length as before, so we'll go out to 0.6, and this y-axis is basically independent because we're doing a speed as opposed to a position, so I can stretch it however I want to make a nice convenient line. Okay, and then likewise with this one, actually we want some scale that's like from 0 to somewhere in the 15 or 20 range, and time axis we want to be about the same length for all of them. Okay, so that maybe looks about like this. To set these up, there's a highlighter tool, which is this guy right here. There's also an equation fit tool. And there's also a statistics tool, which we actually want for the acceleration graph. I'm not especially interested in highlighting any particular range, but if you wanted to, you can drag the highlighter and then resize it so that it's covering the range of values that you're interested in. You click on the little drop-down menu. You see that it's curved. It's quadratic. You can actually see the other part of the parabola over here. I'm going to drag the equation of fit here so that I can see it. This right here, I'm going to do the same, but it's linear. So I'm going to put a line of best fit in and drag the linear. And this one right here is all we want is just the mean value. Okay, from there we're basically done. We might retitle the graph to say something like graph of position versus time or something like that. And then, oops. That like that. And there we are. And we're done. Basically what we would do is we would hopefully be able to click on this, copy it. You should be able to open up something like Microsoft Word. And then when Word is open, ideally you'd be able to paste it in here. We'll see if this is the one thing that finally breaks the camel's back. Let me resize this so that it actually fits in the screen. Nope. Yeah, this apparently is the straw that breaks the camel's back. We can't copy that correctly. Okay, so let's see if I can copy it with a right click. Copy. Nothing at all. So this would be a point where Natalie, I guess, would need to copy them. So go ahead and copy it. So in fact, no. In fact, we're going to do this because I have access still. I am going to go to Word on her computer, going to open it up,
Yeah, that's fine.
and I should be able to paste it now. Let's see. There it is. Okay, so we've copied the graph, we've pasted it. You're going to want to do this for all of your graphs into Word because then you can send the Word file somewhere. When you've put the whole Word file together for what it's worth, you can save it, but ultimately you're going to want to basically make a PDF file of it for upload purposes, or you're going to want to print it out to hand in person. Okay, so you copy each of the graphs over and so on. The other part of it, of what you're doing in this lab, is you have to basically, oops, missed one. You got to be able to copy all of this over into an Excel file. Okay, so we click on that, we minimize that, open up Excel, blank, and then we just paste it in here. What you're going to do is you're going to make a delta T, a delta S. I made a decta. You can fix that. So Natalie's fixing the typo there. Oops, too far. And then there's a T average, and let's see, 1, 2, 3, 4, 5. We need one more. We have V average. And we can include units if we want. This is seconds, this is meters, this is seconds, and this is meters per second. So now that we have that, we just type in the equation. Delta T is the change in time. So it's always time minus previous time. Delta S is change in position. So it's position minus previous position. Average time is the average of the two consecutive times. And this one right here is always the distance divided by the time. Once we filled those in, we actually can sort of drag them down like this. It fills in. These right here are actually intentionally blank because there is no time here or position here to subtract these two from in order to get the values that would go in here. So once we've done that, the next step is actually to insert a graph. And so you'd go charts and scatter like this. This is not at all the scatter plot that I want. So I'm actually going to remove everything. Get rid of all of it because it's all wrong. That's Excel for you. We want to select data, we add it. The X series values are actually the average times like this. Whoops. And then the Y series values are the speeds like this. And done there. You say OK. You're going to want to add a chart title, some labels to the axes, and ultimately also a trend line. Trend line, when you put it in, you need to have linear, and you display the equation on the chart. Once you've done all that, then you're good. You've done what you need to for here. You will ultimately need to basically copy this right here, put it into that same Word file. So after your graphs, you'd have your data table, and then you'd need to have this graph appropriate labeled, and here you are. And you know, you've got 2 more graphs after this one that you've pulled out of Pasco. Okay, so that's the basic setup. Since I have multiple classes that are going to use this video and I don't want to take up too much time, I'm going to actually show the other hardware setup that you could do for, say, kinematics with the motion sensor. So you need to plug the motion sensor in. This is the setup that goes more with this lab right here, just kinematics. Okay, and this one is we're actually doing in physical science, though not physics this semester, but we usually do it in the physics lab as well. What we're going to do is we really don't need the data table for this, and we come over here, we plugged it in, there's automatically a motion sensor, so it already detects it, and all we're going to do is change these to the motion sensors. So it's position, it's acceleration, and then, oops, I clicked on the wrong part of speed, it's velocity. And so once we have those, we make sure that our sensor is ready to go. We should hear a clicking sound when I click it. There's a clicking sound. Natalie's moving her hand in front of it, and it's picking up basically her hand. When you do that in class, for what it's worth, so this is no longer a quadratic formula, by the way, but when you do that in class, you then use like a large board, like a target board, like, of course the camera doesn't see it with the virtual background. It's my active camouflage board. Anyway, you use a board so that you've got a big surface to look at. And probably your graph actually will look similar to what we've made here, because you won't necessarily be doing the motion you're supposed to the entire time. So this is a good example of where you would want to use the highlighter. So you'd highlight part of the motion where you were actually moving, and then you'd say, okay, maybe that part is quadratic. Okay, and so here's that part of the motion as a quadratic, and you'd probably want to zoom in on just that portion, you know, and have it highlighted and so on, so that we can see, yes, this is in fact quadratic or whatever. And then you do likewise with these. So I just highlighted around 2.5 seconds, so I use the highlighter. I put it here around 2.5 seconds or so. My window's a little too wide though. About like that. Zoom, 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 zoom. And about like that. Okay, and so there is my linear fit. Okay, and I would do the same with the last part, the acceleration. Okay, and so you end up needing these equations once again, and that's that if you're physical science. Okay, so at this point we've looked at how to set up Pasco in general. We've looked at how to use Microsoft Teams and do screen sharing and sharing control so that we can work together on this. This will allow us to each be socially distanced correctly. So I'm gonna do here is stop control, and now you know how to do sharing, how to request for control, how to work together on these, how to basically set up the Pasco system, and that's about all we can really do in a video form like this. Just hope that you don't have any computer errors beyond that. My one other recommendation is that when you run Microsoft Teams for these purposes. Don't run it via the browser. Download the desktop app. It tends to be less buggy. It doesn't guarantee that all the problems will go away, as we discovered earlier today, but it will help considerably. So that's it for today.